Alright, we're going to take a look at perimeters and areas of composite figures. Now, a composite figure is any figure that's made up of triangles, squares, rectangles, semicircles, and other two-dimensional figures. So it's composed of multiple different parts, which is why we call it a composite figure. So to find the perimeter of a composite figure, just find the distance around that figure like we always do for finding perimeter. And to find the area of a composite figure, you can separate it into those separate figures with known areas. So for example, in this one, which is a trapezoid, so there is another way we could find the area of a trapezoid. But if you were looking at this, you could break it into that square on the left and the triangle on the right and find the area for each of those if we knew the measurements. And then add those together to get your total area. So first we're going to look at this example, this arrow over here, and we're going to estimate the perimeter and the area. So looking at the perimeter, we could go around and see, okay, that's 1 unit, 2, 3, 4, 5, 6, and then going the other way, 7, 8, 9, 10, 11, 12, 13, 14, and then we have and then we have these diagonal segments. And the diagonal pieces are not exactly 1 unit. We're just going to use 1.5 as an estimate here. That's not exact, but just for an approximation. So we'll say each of these diagonal pieces is 1.5. So far we had a perimeter of 14, counting those straight pieces. And then that would be 1.5, 3, 4.5, and 6. So 14 plus 6, we would get a perimeter of about 20. So the perimeter is approximately 20, but not exactly. And then for our area, right, we can count these squares inside. So we can see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 complete squares. And then you'll notice each of these triangles is exactly half of a square. So that would give us a total of 2 more squares. So 12 plus 2, we would get an area of 14 square units. Alright, now let's look at actually calculating some. Okay, so let's find the perimeter and the area of this figure. So on this figure, we can see that we have a triangle and a semicircle. So starting with the perimeter, right? The triangle part is easy. You've got 8 feet here, and then another 6 feet. So far our perimeter is 14 feet. And then we need to find the perimeter of this semicircle. So if you remember, the circumference of a circle is equal to pi times the diameter. And that's for a full circle. So if we wanted to know the perimeter of a semicircle, that's just going to be half of that. So it'll be pi times the diameter divided by 2, right? Half of the circumference would be pi times the diameter divided by 2. So our perimeter will be equal to pi times the diameter divided by 2. And we'll substitute 3.14 for pi and 10 for the diameter, since that's listed here. And we'll divide that by 2. So we get 31.4 divided by 2. Two goes into 3 once. And 2 goes into 11 5 times. And 2 goes into 14 7 times. So we get 15.7 for that perimeter. And we need to include that with the 14 feet for the triangle. So 14 plus 15.7, we get a perimeter of 29.7 feet. Now let's find the area as well. So the area, right, we'll break this down into our triangle and our semicircle again. So the area of the figure will be equal to the area of the circle plus, the area of the semicircle plus the area of the triangle. So let's start with the area of our semicircle. We know that the area of a circle is equal to pi times the radius squared. So again, we know that the area of our semicircle will be half of this. So pi times the radius squared divided by 2. So we'll go ahead and substitute our values here. So we've got pi is 3.14, and we know our radius is 5 since the radius is half of the diameter. So that'll be 3.14 times 5 squared divided by 2. We know that 5 squared is 25. So 3.14 times 25 divided by 2. We'll do 3.14 times 25. 78.5 divided by 2. And we get 39.25. So that's the area of the semicircle. 39.25 square feet. And then we'll find the area of the triangle. So the formula for the area of a triangle is 1/2 base times height. And we know that our base here is 6 feet, and the height is 8 feet, and half of 6 is 3, so 3 times 8, we get an area of 24 square feet for the triangle. So then the area of this entire composite figure, 39.25 plus 24, 63.25 square feet. All right. Finally, we're going to look at this last problem. The center circle of the basketball court has a radius of 3 feet and is painted blue. The rest of the court is stained brown. 1 gallon of wood stain covers 150 square feet. How many gallons of wood stain do you need to cover the brown portions of the court? So there are multiple steps in this problem. First, we need to figure out how much of the court is actually stained brown. So we want to find the area of the court that's brown. The easiest way to do that is going to be to find the area of the entire rectangular piece of the court and then just subtract the center circle that's blue. So first we'll find the area of the court, which will be base times height. So that's 50 times 84. We get 4,200. So that's the area of the entire basketball court. Now we want to find the area of that blue circle. So it has a radius of 3 feet. And we know that the area of a circle is equal to pi times the radius squared. So our radius is 3, so we'll do pi times 3 squared. And 3 squared is 9. So 3.14 times 9, 28.26. So we'll subtract that from the area of the entire court, right? So 4,200 minus 28.26. So we get 4,171.74 square feet. And we need to know how many gallons of wood stain that we're going to need. So we'll take 4,171.74 and divide by 150, right? Because this area, 4,171.74, is the area of the court that needs the brown wood stain. So we're going to take that and divide by 150 because we know that each gallon covers 150 square feet. So let's do our division here. 150 goes into 417 twice. And 150 goes into 1,171 probably 6 times. Let's check. It's 900, so it'll go in 7 times, 1,050. And then 150 goes into 1,200, 1,217, 8 times, that's 1,200. Now, we could keep going here, but you'll notice we have a decimal after 27. So in other words, we need more than 27 gallons of wood stain. So already, right, even if we don't finish, so this would go in once, but we already know it's more than 27. So we need a minimum of 28 gallons of wood stain to cover the brown portions of the court.